This is part 2 of the Baguio ART study titled Technical Contents. It is a transportation engineering study presentation that can be best understood by civil engineering students or professionals specializing in transportation engineering. It has been drastically shortened and simplified to be appreciated by a layman as much as possible. Still, some viewers may want to skip this part and proceed to part 3 and part 4 of this series. This page shows the introduction and objectives of the study. This page summarizes the research methodology used in the study, starting with ocular visits. The research design is related to the questionnaire development. This will be followed by data collection and analysis. Finally, the proposed route will be determined. The population statistics of Baguio were obtained to help determine the potential locations of the stations for the ART in Baguio. The land use map was also obtained to help determine the best alignment and location of the ART stations. A survey and data collection from 500 respondents were taken in Baguio. We gathered the respondents in groups. The groups were given a short briefing on what ART is all about. They were shown pictures, flashcards, and videos on our cell phones or laptops. These will aid them in answering the questions in the survey. Due to our limited time in Baguio, a group was hired to continue the tedious survey for us. Among the data collected in the survey were the origin to destination trips of residents and tourists in the city. In the same survey, vehicle ownership and purpose of destinations were determined and tabulated here in pie charts. The travel costs, travel time, and time to access and disembark for different modes of public and private transportation were determined. They have been plotted and shown here in the form of bar charts. These are the collection and analysis of preferences data tabulated here in bar charts. These are the equations used in the study. A computer program called nLogit was used to make the calculations based on these equations. This shows the flow of the data analysis. These are the tabulated results of the survey generated by the computer program. These are results of the preference surveys. These are the computer outputs of the revealed preference and stated preference models. These are the graphical presentations of the attributes of a respondent and the probabilities of the revealed preferences. These are the results of the stated preference surveys based on different case scenarios. Take note of the predominantly blue segment indicating that the respondents prefer ART as a viable mode of transportation over their current main mode of transportation. The red map here shows the origin trips. The blue map shows the destination trips. The third map below in purple is a combination of both maps. The darkest colors show where much of the traveling activity is generated and directed. Based on the origin and destination trips of the resident and tourist respondents, the proposed route is a single line that runs through the barangays of San Luis Village, Military Cutoff, and Gibraltar. The ART allows accessibility to these areas with large populations and high demands. This alignment is likely not the most efficient since no benefit cost analysis were made as a part of the study. This could not be done due to time limitations. The thesis panelists restricted the group to limit the stations to only 3. There would be no time to conduct a more extensive study that will allow more than 3 stations. Had the group not been limited to 3 stations and given more time, a different alignment and network could have been developed. Even with its limitations, the output of the study would still be useful. It provides a template for succeeding researchers on the application of ART technology in Philippine cities. In fact, based on this DLSU study, an extended study has been made by engineer June Sanchez. This will be the subject of the 4th part of this video.